राधे राधे मेरे भाइयों. Today I'm going to solve a new question of Leetcode 3 to 8. So as I was not okay yesterday, that's why I didn't uploaded the video. From tomorrow, regularly video will come regularly. So let's move further. So question is odd even linked list, right? So what the question is saying, given the head of a singly linked list, group all the nodes with the odd indices together, followed by the node with the even indices, reordered list. The first node is considered odd, the first node will be considered as odd node, and the second node will be the even node, and so on. Means alternate odd, alternate even. Note that the relative order inside both the even node groups should remain as it was in the input. Means if the 1 is coming before 2, it should always come before 1. It should always come before 2 in the reorder list. You must solve the problem O of 1 extra space and O of 1 time complexity. Means you do not have to take extra space complexity and time complexity you can take at most of O of n. So let me tell you the question in better way. So as in the given test case, okay, 1 2 3 4 5, right? So what the question is saying now, you have to arrange the linked list in odd and even indices. Like this is odd indices and this is even. Again this is odd, this is even, this is odd. So what, in which order you have to arrange? First the odd will come, so 1 3 and 5, then even will come, right? As you can see, odd was 1 3 and 5, so 1 3 5, then 2 and 4. So you have to arrange the linked list in this order. So the odd indices nodes will come first and then even indices will come, right? So as the constraint is saying, you do not use extra space, but we will see first, like the brute force we should know how we can solve. So the brute force will be like as the given linked list is 1 2 3 4 5, right? So what we can do, we can make a list of odd and make a list of even linked list, actually linked list, and we can simply add them both. So how we can do, like when we are traversing to the linked list, see 1 2 3 4 5, right? So when we are traversing to the linked list, if the if this we can denote as a first index, this is second, this is fourth, third, this is fourth, this is fifth. So we can take a temp variable dex is 1. So if it is divisible by 2, means it is even. If it is not divisible, then it is odd. So if it is odd, then we can simply add into the odd linked list. If it is even, we can simply add into the even linked list, and then at the end we can simply add both, and then simply we can return those, right? So it will take O of n space complexity. Time complexity is fine, but space complexity we are taking more than the constraint. So we will try to optimize it, right? So how we can optimize it? 1 2 3 4 5. So let's see. As you can see here, this is odd, right? And this is sorry, this was the node, this is even. We have to connect what? So we have to connect the alternate nodes, 2 to 4 and 4 to null, right? As you can see here, like if the linked list is looking like this, 1 2 3 4 5 6 and 7. So how we have to do? We have to simply connect the alternate node, 1 to 3 3 to 5 5 to 7, then 2 to 4 4 to 6, and then we, after adding these 4s, we can simply add these 4 to these 2s, right? We can do like this. So the approach is simple: 1 2 3 4 5, right? Just like if it is odd, this is odd node, this is even node, okay? We have to simply connect all alternate node. Mean this will be connected, this will be connected, then this with the null, right? And first thing we have to, like, first odd will come, then even. Means we have to keep the last node of odd. Means the odd linked list we are connecting, we have to keep the last, then only we will add to the events head now. If we do not have the access of last node of odd linked list, we cannot add to the even first, right? So this is the key point. I will tell you later why I told you this. So as you can see, odd was here. So what I can think, can I add odd next to the even next? See here, 1 2 3. If this is 3 node and this is, if you want to connect these twos, can you take the help of this node? If you have direct access of next this next, you will get this. But if you want to add this, you can take help of this node, right? So this next means 1 next will be what? 2 next. So it will be connected to directly to 3 because 2 next is 3. So 1 next is equals to 2 next, means 1 next will be connected to the 2 next, that is 3. So simply we will do here only, right? As it was, I am drawing so many times that single English, so don't think that much. So odd and even, right? So we'll simply connect what? Odd and even next to the odd. So it will connect it like this. And after we know, if there is even next, then only we can move odd to the next position. What I told you, we have to keep track of the last odd index. Why I told you? Because if you don't have a last odd index, how will you connect to the even first? Like some odd was there and some even linked list was there. If you want to connect both these two, you need to access this pointer, then only you can add this now. So you need to keep the access of odd, because odd we have to add first and then we have to add even, right? So odd next will be the even next. You can simply say this, and then we can send odd to the even next, right? Means odd will come here after. Now I want to add 2 to 4. So how I can add 2 to 4? You can see, you can take the help of odd next, right? Sorry, let me, okay. So you can take help of odd. So odd next will be what? Even next. If you want to connect 2 to 4, 2 to 4 you want to connect, so you can take help of 3. 3 next will be what? 4. So you can simply add 2 next is equals to 3 next. Next is the next pointer. So this next will be connected to the this next, and you will keep doing this until you do not reach to the odd, means last node, or this is even last node. Like this is odd linked list, right? Odd length linked list. If you have even length 1 2 3 4, so odd will be here and even will be here. So odd next will be what? Even next. And if even is there, if even next is there, if then you have to move what? Odd to the even next, because you want to keep the last. If you move odd to the null, how will you connect to the even head? Then you are checking this, and after doing this, odd is here only. Odd is here after this operation, and this much of operation, odd is here only. Now you want to connect even to the 2 to 4. How will you connect? So you will simply, even next will be what? Even next will be odd next. Simple. Means we are simply rearranging the nodes. Odd next is what? 4, because odd is here. So odd next will be what? 4. So you want to connect 2 to 4. So E next will be odd next. Odd next is 4. So even next will be 4. So 2 will be connected to this. Now there are two linked lists. One is 1 and 3, and second is 2 and 4. But you lost the access of odd is here and even is here, right? So you lost this one. You have access of the last node of odd, means odd linked list. Odd is here, means you have access of last, but you want to access of also the first one. So at the starting only you keep a node here only at odd starting index, and a node with even starting index, so that you can keep track of the head of both linked list after reordering, right? So as the odd linked list head is here only, so what you will do, odd last, you know that odd last is here, so you will add the end. Odd next will be what? The head which I already put there is before doing the rearrangement. Odd next will be what? Even head. So 1 3 was already there, and 3 next will be what? 2, and 2 have already made the linked list 2 4. So answer will be 1 3 2 and 4, right? So I will take another example to explain. Let's see, 1 3 2 4 5 6. This is the test case I have taken. Let's see. So odd here and even is here. So first I will connect odd next to the even next. I have connected, means 1 will be connected to the 3. Now I send if even next is there. If even next is there, is even next is there, yeah, even next is 2. So I will send to the odd to the odd next, or you can say even next, you can also write. And after doing this, what I want to say, now odd is equals to odd next. So odd is here only, odd is, and odd has and there is a node that is even head. It will already it will be here only every time, because you want to add odd last to the even head, so that you can connect both even and odd linked list. So 2 is here. Now odd even next will be what? Even next is equals to odd next. Now we want to connect this na 3 to 4. So how you can access 4? Odd next will be 4. So even next will be the odd next. So now 3 will be connected to 4. Now even will come to odd next. Even will come to even next. Means even will be moved to now here only, and E will be removed from here. Now again loop will keep running until odd next not equals to null. Why I'm writing odd next? Because if you if you put the odd to the null, how will you connect to the start of even? So you need the odd index as it should be at the end. It should not be null, and as well as even should not null. Even should not null. So odd is here, even is here. Again it will come to the even next is equals to odd. Odd next is equals to even next. So even is here, so odd will be connected to 2 is connected to 5, and even next is equal to odd. If even next is there, even next is there, yeah, even next is there 5. So I will simply send odd to the odd next. Odd will be come to here, and odd will remove from here only, right? Again even next is equals to odd next. Odd next is what? 6. So even next will be connected to the 6. Now even will come to the here, right? Again, is odd next equal to null? No, odd next not equal to null. So what I will do, if odd next is equal to even next, so odd next equal to even next means odd next will be connected to the null, right? And if even next is not null, but as you can see even next is null, so I will not send odd anywhere. Odd will be here only. And now even is at the last node, so I will not add this. So the linked list will look like this: 1 1 3 4 1 2 5 1 2 5, and then 3 5 6. I hope you understand the question. First I told you the brute force. You can add you can simply make 2 linked lists, then you can add. Now the brute force was you can simply rearrange those that nodes. If odd next is there, you can simply connect to the even next, and even next is there, simply connect to the odd next. Sorry, my wait. Yeah. So I will write the code to while odd not equals to null, means odd should always be the last node. It cannot be null, because at the end you want to be able to add to the even head. Even next not equals to null, right? So first odd next will be even next, and if even next is there, if even next not equals to null, then only we have to move the order to the next one, because I want to keep the odd. You cannot put odd as null, because you want to be able to add the odd. I am saying again and again and again. Even next will be what? Odd next, and even will be the moved. You don't care about even can be null, but odd cannot. Even last can be null, but odd last cannot be null, because after reordering linked list, the even will be come at the last side. So at end even next will be null at somewhere, so you don't focus on that. So this is the code. So I hope you understand the question, and I will put the link of the code in the description. So I'll be meeting you in the next video. Till then, take care. Bye bye. Jai Shri Ram.